In this example, we want to round to the leftmost digit to find the approximate answers to each of the calculations, and then we're going to compute the exact answers. Now we're going to first take 681 and stack it over 241. Now rounding to the frontmost digit is called front-end rounding, and so 681, we underline the 6, the 8 will bump that 6 up to a 7, and everything after the underline becomes a 0. Again, down below we have a 2. We look to the right, that 4 is not big enough to bump that 2 up to a 3, and so we keep it as 2, and everything to the right of the underline becomes a 0. And so 681 rounds to 700, 241 rounds to 200. 700 plus 200 will give us an estimate of 900. Now we are going to add 681 with 241 in the traditional addition algorithm to compute the exact answer. Starting on the right, 1 plus 1 is 2. And then in the tens, 8 plus 4 gives us 12. We're going to put a 2 there and regroup the 1 to the hundreds column. 1 plus 6 is 7, and 7 plus 2 is 9, and so the exact answer is 922. In this subtraction problem of 631 minus 287, we are going to also use front-end rounding to subtract the numbers and then find the exact. So we have 631 minus the 287. We're going to use front-end estimation or front-end rounding. Underline the 6. The 3 next to it does not bump that 6 up, so the 6 remains the same. Everything else becomes a 0. Estimating here, or rounding here, the 287, the 8 is big enough to bump the 2 up to a 3, and then everything else becomes a 0. In this problem, we are going to subtract 600 minus 300, and that gives us 300. We are also going to find the exact answer of 631 minus 287. That's going to involve regrouping. 1 minus 7 isn't possible with positive numbers, I should say. And so I'm going to regroup by subtracting a 1 from this 3, and so I get a 2 there. And this 1 here becomes an 11. And so now we have 11 minus 7, which is 4. Moving in the tens place, 2 minus 8 will give us a negative number. And so we want to regroup this 6 in the hundreds place to be 5 and add a 1 to this 2 so that we have 12. 12 minus 8 is possible using positive numbers, and we get a 4. And then lastly, in the hundreds column, 5 minus 2 gives us a 3. If we take that 344 and we front end round it, the 4 isn't big enough to bump that number up, and so we have 3 and then 2 zeros. And so this estimate by front end rounding of 631 minus 287 is approximated really well to be 300, even though it's 344. In this problem, we have 548 times 359, and so we are going to use front end rounding. So we have the number 548. We will look at the 5. The 4 is not enough to bump it up, and so we have 5 and the 2 zeros. For the 359, we underline the front end, the 3, so that's the nearest hundreds place. The 5 is large enough to bump that 300 to a 400, just like that. And so now we have 500 times 400. 5 times 4 is 20, and then there are 4 zeros after that. And so our number here is 200,000 as an estimate. For the exact multiplication, I am going to use the traditional algorithm to multiply these two numbers together. 8 times 9 is 72. So I'm going to regroup my 7. 9 times 4 is 36. 36 plus 7 is 43. 9 times 5 will give me 45. 45 plus 4 will give me 49. What I do now is I usually cross off the numbers I regrouped so I don't get them mixed up in my next level. I move down a level. I want to start multiplying by 5, and so I use this placeholder of 0 there. 5 times 8 gives me 40, and I regroup. 5 times 4 gives me 20, plus another 4 gives me 24. So I put my 4 here, and I regroup. 5 times 5 gives me 25, plus 2 gives me 27. Again, I come back and cross out my regrouping so I don't get them mixed up in this problem. Now I'm going to start multiplying that 3, as in 359, by each of mine. First, I will use 2 placeholders here of zeros because I'm multiplying by 300. So 3 times 8 gives me 24. Regroup my 2. 3 times 4 gives me 12, plus 2 more will give me 14. 3 times 5 will give me 15, plus 1 more is 16. And then I'm going to add each of these numbers together. 2 plus 0 is 2. 3 plus 0 gives me 3. 9 plus 4, well, the 4 plus 4 is 8. So 8 plus 9 gives me 17. I'm going to regroup my 1. Let's see, we have 1 plus 4, that's 5. 5 plus 7 is 12. 12 plus 4 gives me 16. So I put a 6 here and I regroup my 1. 1 plus 2 gives me 3. 3 plus 6 gives me 9. And lastly, nothing to regroup there, lastly, my 1 by itself. And so the exact answer for 548 times 359 is 196,732. And if we front end round 196,732, it will absolutely round to 200,000. And so our estimate of 200,000 is really good for our multiplication, our product of 548 and 359. In this problem, we're going to use front-end rounding to estimate our quotient of 57,801 divided by 336. and then we're going to perform an exact division. And so 57,801, if we front and round it, we're going to look at the 5 out front. Is the 7 big enough to bump that up? Absolutely. It's going to become a 6 with everything else turning to zeros. And then we have our 336. We're looking at our 3 out front in front end rounding for our estimation. Is the 3 behind it big enough to bump that up? Absolutely not. So that stays a 3, and those two become zeros. And so now we will still have to do long division. It is a little bit easier in this case because of all the zeros. We can do it like this. Okay. We can imagine how many times does 3 go into 6, and that is 2 times. All right, so where do we put our 2? Just imagine it as this. 300 times 2 will give us 600, and so that 2 goes in this place right here, because that 600 will line up nicely with this to give us a remainder of 0. We move these next 2 zeros down, and so how many times does 300 divide into 0? 0 times. How many times into another 0? 0 times. And so we have 60,000 divided by 300 is 200. Another way to do this with all of these zeros is to have 60,000 over top of the 300, and this is a quick method. We could cancel these zeros like this, and then just have 600 divided by 3, and 600 divided by 3 is 200. So that's another way to do this using a quicker method. With front end rounding, the estimate of 57,801 divided by 336 is 200. Now we will do the exact answer of 57,801 divided by 336. And so 336 is our divisor with 57,801 underneath. And so we start off by saying, does 336 go into this 5? No. Does it go into 57? No. Does 336 divide into 578? Yes. Most likely it only goes in one time, but over on the right-hand side in my work, I'm going to show 336 times 2, just in case. And so 6 times 2 is 12. 2 times 3 is 6, plus 1 is 7. 2 times 3 is 6. So that's 672. That's a little bit too big. And so it only goes into that one time with 336 as our product there. Then we will subtract those two numbers. 8 minus 6 is 2. 7 minus 3 is 4. 5 minus 3 is 2. Next thing we'll do is bring down this 0. And so we have 2,420 divided by 336. Well, over on the right-hand side, I've already multiplied by 2. 3 probably won't be enough, so I'm going to try 336 times 4, because 6 into 24 for the 2420 is 2 more, or is 4 more, so that might work in terms of just trying things out. So I have 336 times 4. It might be larger than that. Maybe it's times 8. I think it might be times 8. I think I messed that up a little bit. But let's try 4 anyway to know that we have to go larger. 6 times 4 is 24. 4 times 3 is 12. 13, 14. 4 times 3 is 12, plus 1 more is 13. So yeah, we see that that's half of, or approximately half of the 2420 there, so 336 times 8. And if that's too large, we're going to have to go to 7, and that's okay. It's okay to have extra work over on the right because you'll never know when you need it. So 336 times 8, we have 6 times 8 is 48. 8 times 3 is 24, plus another 4 is 28. 8 times 3 is 24, 25, 26. So yeah, that was a little bit too big there. So I'm going to come over on the left because I ran out of room on the right hand side here. So 336 times 7 might do the trick here. 6 times 7 is 42. 7 times 3 is 21, plus 4 is 25. 7 times 3 is 21, 22, 23, and so we have 2352. And so 2420 divided by 336, the best we could estimate is 7 there, because we'll have 2352 down here. And we're going to subtract that. It's going to involve some regrouping. So we have 10 minus 2 will give us an 8 for the regrouping there. 1 minus 5 is not going to work out, so I need to regroup that to be a 3. This becomes an 11. 11 minus 5 is 6. 3 minus 3 is 1, and 3 minus 3 is 0, and 2 minus 2 is 0, and so 68 is the remainder there so far. We're then going to bring down our 1 here. Oop, I'm going to change that to black. Our 1 here. And now I'm going to look around to see if anything's close enough, and I see over here, yay, I already have 2 written down, and so I will use that 2. And we will have 672. We're going to then subtract that, and I have to regroup here. So we have 11 minus 2 is 9. And so this problem does have a remainder of 9. 172, remainder 9. Now, if you remember, on the other page, our estimate was 200. And so if we look at 172, remainder 9, and we front end round that, we will have 200. And so the estimate of 200 on the previous page was a good estimate for this particular division problem.